In this video, we'll continue our discussion of section 14.2. This is over double integrals or iterated integrals. This is summing up the last problem we did. It's called Cubini's theorem. I'm not going to ask you to quote this or anything like that. But all this says is if we're bounded by two numbers and bounded by two functions with my other variable, I would just put the two functions first, look at our two integrals here and here. The function, if that's derived with y, that has to go first. And we kind of mentioned this in the last example because I'm going to have x's in my answer. The same for the bottom. If I have x here that's trapped between two y's, then I need those to go first because I'm going to have y's in my answer. This is going to become obvious for you, especially when you're checking your answers, because we're going to be looking for some type of actual answer. All right, so let's take a look. We're just going to set this one up. So it says set up the integral of the function f over the region R that is bounded by y equals 2x and y equals x squared. You guys have done this graph a million times in your calculus career. Usually y equals x, I think, is what they go for. So what we're looking at here is first we need to find where they actually intersect. Well, you can kind of eyeball this one. This one intersects at x equals 2. When x is 2, we have y to be 4 on both graphs. Okay, so my y equals 2x will be 0, 0 with a slope of 2, which means over 2 it should go to 4. So there's that graph. And then y equals x squared, we see a bunch, goes to the parabola that goes through like that. And we are finding the volume above that region. What you guys have done so far in Calc is you guys have found the area in that slice. But now there's a surface that comes up. We don't know what the surface is. We're just going to call the surface f of xy, just to help us set this up. Okay, so I know we have two different things, and we're always going to, just like in Calc 2, we have to set up this integral since we have two different curves. And the way I like to look at it is I try to find a bottom curve with an arrow to the top curve that is the same all the way across, meaning like here it's also the same bottom curve and the same top curve. Just like in Calc 2, we avoided where it changes curves on us because it gets really complicated. So here then, I know that x is between 0 and 2. We can see that. But the y is going to be between, not 0, but our bottom curve is going to be x squared, and our top curve is 2x. You can see that here, right? This curvy one was x squared, this was 2x. We have a bottom curve and a top curve. So if I'm finding the volume of the surface, it would make sense, it would have to, that y goes from x squared to 2x. I can't put that on the outside because my answer in the end will have x's then. Then that means x goes from 0 to 2. We could also have done this where the x is the bound, and we could have done arrows like this. Right? That would have worked too, except for now, x would be caught between, and we'd have to put it in terms, we'd have to like solve them for y. So when it's in nice terms like this, maybe we should leave it. But if not, what we have to do, okay, that the x squared is actually the square root of y. And the bottom one is y over 2. You have to like solve them for x's. So that's what we'd get if we wanted to flip it the other way. But leaving this is fine. We'll get to the same answer. I like using squares and 2's times 2's. Those are easier. But here's an important part as well. That has to be a dy dx. Because y is on the inside, x is on the outside. We can't solve this because we don't know what the surface is. But this is how we pick up when we have two different curves that define our region. All right, let's get another example in. So our surface, z, just so we are aware, is x over 1 plus xy. Right? We always try to draw our region. This one's nice and easy. Let's do that. It just goes from 1 in each direction. So we are just talking about literally the rectangle right here. So we want the surface is defined on that rectangle, 0, 1, any point in there, and we're trying to find the surface above that. All right, so the volume is the integral. Let's space these out because we want to do x equals and y equals. And then I throw my surface in there, and we're trying to think about which one is going to be easier in the way that it is. Well, I see 2 x's, and I see 2 y's, 1 y, so I'm going to go with y first. It's simpler. Our bounds are 0, 1, 0, 1. I'm not even going to put x equals or y equals because, well, we still need that actually. They're the same, but y equals 0, y equals 1. The reason I'm going to do it is because we got to plug it in a moment, and it'd be nice to know which one to plug it in. The whole point we do it. All right, so x equals 0, x equals 1, and we're going to integrate with respect to y. This takes a u sub. I'm going to erase our picture since we know what it's going to look like. Our u sub is going to be 1 plus xy, which means du. Remember, we're doing it with respect to y, so that's going to be x dx. So, or dy, x dy, because we're taking it with respect to y. Hopefully that makes sense to you. U is u, and then we're taking with respect to y. And it's confusing, I know, but you have to just base it on what's going on here. All right, so we do this u sub, and we get, I need to write these bounds. And let's go ahead and change, we can change our bounds. We have y equals 0, so if I plug a 0 in here, I get u equals 1. If I plug a 1 into there, I get u equals 1 plus x. That's totally fine. Then I got 1 over u, du, dx. All right, so I'm not going to be happy about this one, but this integration will show up a lot. You got to get this down. This is one you want to know. When you get to diffy q, we do it a lot. All right, so this is ln of u. I don't need to put absolute value because the absolute value comes from, it needs to be positive, right? But if we look at our bounds here, x is always between 0 and 1, y is between 0 and 1, this is u. Well, if x is between 0 and 1 and y is between 0 and 1, u is always going to be positive. So we have u there, it's always positive, I got a dx. Then we get to plug this stuff in. So x equals 0, x equals 1. We get ln of 1 plus x minus ln of 1. Hopefully that is a red flag for you. ln of 1 is 0. So I'm going to drop my bounds because all I have are x's. So this is what I get here. All right, if you don't remember the integral of an ln, that's okay. You can use a table. I will provide some kind of table for this section for integrals. It's not really what I'm worried about. It's more of all the other stuff. Okay, so the integral for that ln is 1 plus x, ln of 1 plus x minus 1 plus x. We are doing this from 0 to 1. This ends up being 2, ln of 2 minus 1. We can bring that 2 up to a power, so we get ln 4 minus 1. If it were me on a test, I'd stop right there. I wouldn't go any further just in case we mess up. But if the book answers are going to look more like this. All right, so that is the volume. You could go if you wanted to and get an approximation. That's fine if you wanted to. Here's example 6. We'll do one more for this video. All right, so this region, notice x is between 0 and pi, and then cosines between those two functions. Those functions are going to be ridiculous to graph, so I'm not going to bother because I can see how it's defined between x and y. I don't really need the picture there. They defined all the x's and all the y's for us. Now, the question is, which one goes first, inside meaning? Well, it's going to have to be the y because the y has x's in it. And we want our final answer to not have any variables. All right, so we have that. I know it seems real complicated. Then we got 1 over y, ln of y. I'm going to rewrite it. This says dy, and then we have dx on the outside, so x is 0 and x is pi between those two. All right, we're set up now. We want to do a u sub. There's no way to integrate that the way it is. So our u sub is going to be u ln of y. The reason I picked that is because when I do du, I know that the derivative of ln of y is 1 over y dy. That actually covers almost the whole problem. Makes it very, very easy for us. So this is x equals 0, x equals pi. We could actually plug the bounds in. It's not too bad. So u is ln of e to the cosine x. That's actually just equal to cosine x. So that's good. U is cosine x. You can see how the other one is going to react as well. Ln e to the negative 2x is negative 2x. Makes our problem even easier. Then we just have a u, du, dx. That came from all that u sub. We replaced du with all of this, so that's why this and this are gone. Those two are gone. We also replaced u, ln of y with u, and then we changed our bounds. Right, so this is a nice easy integral. X equals 0, x equals pi. We get u squared over 2 between negative 2x and cosine x dx. So we're going to plug all that in. I can let go of my bounds now because I only have x's. I'm going to get cosine. Let's go ahead and pull the 1/2 out if that's okay. So let's do that. 1/2 with the integral from 0 to pi. I don't have to write my x's because that's all I got now. And I get cosine squared x minus 4x squared dx. Now this is just a normal integral. I'm not going to work out the cosine thing. Let me look this up. This is an identity or an integral. Give me 1 sec. All right, we could do some u subs with that. There's also some trig subs, stuff like that. Let's see if we can find one here. Cosine squared x is the same thing. Okay, I got 1/2 times 0 to pi, and then I can actually replace this as a trig identity. We get 1/2 1 plus cosine 2x minus 4x squared. This will allow you to do the integral nice and easy now. So what this ends up being, in the very end, I'm out of room here, so that's just a u sub there. So just be careful with that. Oh, this is a mistake. This should be an 8 now because I pulled out the 1/2. So just be careful with that. That came from here. I pulled out a 1/2, so I need to take account of that 8 getting back to the 4. This works out to be not too clean. It's a pi over 2 minus 2 pi cubed over 3. Once you get to this point, you can use a calculator. A lot of them will actually do the integration for you. Look up definite integrals for your calculator. If you have the one I recommended, TI 30XS, that one will do it. There's another one that engineering, I would actually recommend this one too, TI 36. I think there's an XS, I'm not sure. This is an engineering calculator. It's used, I even found out that's used at OSU. So here's our answer to that. Work this integral out. See if you can do it. It's just Calc 2. Again, I won't hold that against you. You could actually just use a calculator at that point if you know how to, or work on the integration, whatever you prefer.